Hello and welcome back to Harry's workshop for another of my little Jeti clinic videos. And in this one, we are going to be looking at a vectored thrust unit in combination with gyro stabilisation being switched on and off. And you might think, well, I don't have vectored thrust unit, I never will, I don't even know what it is, but I'd still recommend watching the video anyway, because a lot of the things we might be doing in this could well apply to a situation you have in your model. So it might not specifically be vectored thrust, but you might think, oh, I didn't know I could do that, or that's a good idea, I'll use that and do it in my model to get some outcome. Okay, so what are we talking about? Well, this particular request started off from Jens Abo. Hello, Jens. And he has a jet model, a Saab Avio Lizard. I've seen these at the model shows like Jet Power in Germany and the Weston Park show in Britain, and very entertaining it is. It's a delta wing model with a canard and a vectored thrust unit. A vectored thrust unit is like a little short jet pipe at the back of the model, and it's on gimbals and operated by two servos, so it can work in pitch with your elevator.
Inactivity alarm.
And it can work in yaw with your rudder. And Jens wants the assist gyro to stabilize the vectored thrust unit. Great, except that he also wants, of course, to be able to switch the vectored thrust unit on and off. Well, that's easily done, but needs the assist stabilization to stop stabilizing the vectored thrust unit when he switches the vectored thrust off, but continues stabilizing the rest of the model. And he wants two different stabilization modes when the vectored thrust is on. He wants a hover mode, in which the vectored thrust stabilization, and indeed the whole model, would be in heading hold mode. A normal vectored thrust mode, where all the stabilization, including the vectored thrust, is in normal damping or rate mode. And another normal fly around mode, where the model is in normal damping stabilization, but the vectored thrust is not being stabilized at the same time that it's switched off. Now, a further complication that Jens threw in and asked about is that this model has two fins, two rudders, and Saab recommends setting up the rudders moving in together as an air brake. And Jens was asking about that. But there's an interesting problem here, because if you select model type Delta, then it has no tail type. And although the Jeti will put in a rudder by default for you, there's only one, and it creates some interesting problems compared to a tailed model, which could also have two fins, and you've selected the 2H2V, and so your braking or setup of the rudders would have to be a different way. So I promised Jens I would include the rudder braking in this, but what I'm going to do is separate that out into another video, because it's worth looking at because of the differences between a Delta and a conventional tailed model due to the way that the Jeti is set up. Okay, so we'll do that in a different one. Now, there's one other thing I'm going to throw into the mix here, and that is to show you how to get it set up on a conventionally tailed model with your vectored thrust. It doesn't make any difference to the vectored thrust, but it might make a difference to your flight modes. Because if you have a conventionally tailed model, you've probably got flaps, and you might want a landing mode and a takeoff mode. And you can do, set up your flaps through the butterfly on flight specific modes, and you can set the elevator trim to be flight mode specific, and that's all hunky-dory. Obviously, those two modes, landing and takeoff, would not apply with the Saab Avio Lizard, which is a Delta, and Deltas don't have flaps. However, I'm very briefly going to show the two additional modes in the flight mode creation here, because it is important to get your flight modes in the correct sequence, and we'll see why when we get there. Otherwise, for anyone who's programming a delta, such as the lizard, you can ignore those two little bits of it. But we'll see that in a second. Right, let's go in and have a look at what we're trying to do here. And so first of all, we look in our model. The basic properties, just set up the way you need them. And functions assignment, you get the standard ones come. Right, here's the ones for the vectored thrust. We'll create a function called pitch, and we assign it to whichever is your elevator stick. We create a function called yaw, and we assign it whichever is the rudder stick. What else will we have? We'll have a gain channel, which will not be assigned to any control. In the early stages, I think you probably will assign this to a rotary knob, such as P8, for example, because you will need to tune your gains to find what's optimal. But I'm going to show you what to do after you've set that, so that we can have the gains all moving around in the different flight modes. Okay. We need a gyro mode. Now, this is inside the assist. Remember, you can select assist modes 1, 2, and 3. And thank goodness they've given us at least 3 gyro modes, because if you remember what I said earlier on, we're going to need them, because we need a heading hold mode that stabilizes vectored thrust as well as the model. We need a normal mode that stabilizes vectored thrust as well as the model. And we need a normal mode which does not stabilize the vectored thrust. So there's 3 different modes of the gyro we're going to need. So again, we set a function for it, but no control. And the big reason for setting the gains and the G modes is that having created them, it allows us to assign channels or servos to them, but it's channels, and therefore, you know, something's being transmitted to the receiver. And it also gives us function curves. It gives us anything relevant to the fact that a function exists. So we've got dual rates, function curves, etc., and we are going to be using them. But the big thing is you need them so that channels are created. Okay. Servo assignment. There we go. I've just kept the rest of this very, very simple, because what we're really interested in this model is pitch and yaw for the vectored thrust, the gyro mode, and the gain. Okay. Obviously, as well, you would have set up a gyro master switch, the master I call it, which is the switch where you can switch the Jeti assist on or off. But it's not part of this demonstration, so I've not bothered to putting that in, because hopefully by now you should know all about that. Okay, and then into fine tuning, flight modes. Okay, here I've set up flight modes as if we had a normal tailed model, because you do get some with vectored thrust, such as I think the Karf Mephisto, and there will be others. Basically, you can fit a vectored thrust unit to just about any jet model. I suppose you could fit them to a ducted fan if you could get enough thrust to make it worthwhile. So if you've got the Sabavio Lizard, which is a delta, then you don't need the landing and takeoff modes. Yeah. You just go straight to your VT normal, VT hover, and default, and thus your 3-position switch would switch between them. I'm using switch SA to switch between them, so that would be VT hover, VT normal, and with nothing on, go to default your normal flight mode. If you've got a tailed model and you want landing and takeoff modes, and I always use them, then they must go higher up the list, in other words a lower number, than your vectored thrust modes. Doesn't matter which way round they are. You could have takeoff and land, land and takeoff, but you want them at the top. You want your normal flight mode, the default. You can rename that to cruise, normal, mess about, whatever. I just tend to leave it as default, so I know exactly what it is. You want that one at the bottom. So that's your normal fly around mode. Yeah. And the reason you want land and takeoff there is so that if you switch either of them on, it overrides the vectored thrust mode. What do I mean? Well, you should have watched my video about managing flight modes, but very briefly, it's possible to have several flight modes switched on at once. Which one will the Jeti choose to use? Well, it reads down this list here, and the first one it comes to with a tick, it uses. So in this case, that's the first one with a tick it uses. Default mode is always ticked in effect. So if I switch it off, Jeti runs down here, the last one, which is in effect always ticked, is the one it uses. If I switch on vectored thrust normal, that's the one it uses, vectored thrust normal. What happens if I switch on landing mode or takeoff mode? There we go, I've switched to takeoff mode. Now, two different modes are switched on. Which one does Jeti use? Runs down the list. That's the first one. So here we're in takeoff mode. So takeoff and landing can override the vectored thrust modes. Rather useful if you are going to take off, you put your flaps to takeoff position and you've forgotten that you've got the vectored thrust switched on. Well, the whole system will revert to takeoff mode, not the vectored thrust mode. If you had these swapped the other way round, you could accidentally take off in vectored thrust mode. Okay, but say if you're running a delta, just go straight to those, and it doesn't matter which way round you assign them, because if you're using a single 3-position switch, it could only ever be on in one position. Right you go. Digital trim, do what you want there. If you want, set things like your elevator to be separate rather than global. Flight mode trim, I don't think there's anything needed there. Dual rate expo, right. This is where, as you can see, we have got pitch and yaw because we created those functions. And as I've said in other videos, with the sophisticated computer transmitters, there's several routes to achieving the same thing. And in this case, I've chosen to go down this route to achieve the switching off of the vectored thrust unit. I'll take the flaps back to the normal mode. So now I'm choosing between vectored thrust hover, vectored thrust normal, and no vectored thrust, the default mode. Okay, if we go into the dual rate for this, what I've done is set the pitch to be separate per flight mode. So, and that means we get a new curve for every individual flight mode. So, we're in default mode. I have set the pitch curve to have no rate at all. Come down here, show you, I can swing it up, swing it back down, get it to 0. I shall move the vectored thrust switch to switch on vectored thrust, VT normal. So I've left that as the normal 100% curve. I'll move the switch again, VT hover, again, we've got the normal curve. What if I move the flap switch so that we move to takeoff mode? Takeoff mode, a new curve, I've set that to 0% rate. Landing mode, 0% rate. So there is how we're switching the vectored thrust on and off, for pitch anyway. Landing, no rate. Takeoff, no rate. Default, that's our normal fly around, no rate. Vectored thrust on, for normal mode, we've got a rate. Vectored thrust to hover, we've got a rate. Okay, so we come down here. Let's look at doing it for yaw. Again, we go along, set it to separate. So let's have a look at doing it. VT hover mode, we'll leave the rate as 100. VT normal mode, we'll leave the rate as 100. Default mode, we don't want any vectored thrust, so we come down here. I'll double press the menu so it's times 100, so one click of the button takes me to 0. Now, we don't have to come out of this field. We're still in there. The button is still acting as a 100% per click. I will now move to takeoff mode. I don't have to reactivate this. I just do one anti-clockwise rotation of the programming dial, and we're at 0. Go to landing mode. Again, I'll just do one anti-clockwise rotation of the programming dial. We're at 0. And now we can test them all. Landing mode, no vectored thrust in yaw. Takeoff mode, no vectored thrust in yaw. Normal fly around mode, no vectored thrust in yaw. I will now go to vectored thrust normal mode. We have a rate. Vectored thrust hover mode. We have a rate. So there we've switched the vectored thrust servos in effect on and off. And off will lock them at the 0 neutral position. Okay. Well, that's going well. That's nice and easy so far. Let's have a look at function curves and what I'm up to in here. Once again, because we created the functions, we have a function for pitch, a function for yaw, a function for the gain, and a function for the gyro mode. The pitch and yaw, there's not really much to do there. Obviously, you can go in and create curves. I've left it as global for the moment. If you really want to, you could change that to separate and create separate curves for them. What I'm really interested in here is making them separate for the gyro gain and the gyro mode. Now you're thinking, yeah, why didn't you do that in joule rates? Why are you doing it in function curves? Well, I'm doing it in function curves because if you turn the joule rate down to 0, what you've done is lock the servo at its mid position, or the channel output at mid position, 0%. You can't have anything other than 0%. Whereas with a function curve, you can have it as a flat line, but anywhere from plus 100 down to minus 100%. And of course, with the gyro mode, that's the 3 modes in the assist, they work on a channel position of plus 100 or 0 or minus 100. That's how you switch between the 3 modes. So what we want to do is be able to manipulate in every mode a flat line curve that is at plus 100 or at 0 or minus 100. And you can't do that in joule rates. And the same with the gain. We'll just flat line it, but we can, having found the gains using a rotary knob initially, we can then lock the gain in for every one of our 3 or 5 flight modes, if you've got a tailed model, at some specific value per individual flight mode. Now you're thinking, what about having used the flight mode trim to do that? Yay, why not do it in here? You could have set the gain and the gyro mode specific in there. No. Flight mode trim is, as the name implies, a trim, not a function. And you know, if you move the trim buttons, they only move the channel or the servo part way. It doesn't have the full travel. So the flight mode trim will go up to 125%, but it's only worth 0.5% of normal travel. So even at 125%, you've actually only got a servo output of, what would that be, 62.5%, not 100%. So that's why we're not using flight mode trims to do this, using function curves. Let's go in and have a little look. We'll use the gyro mode one to have a look initially. Go in here, remember it's set separate. Here's just a quick thought. Before you change it to separate, go in here, change it to a constant curve. Yeah? Come back out and change it to separate. If you've changed it to a constant curve in global and change it to separate, it will now give you a constant curve in every flight mode. If you change it to separate, then go into it and change it to constant, it's only changed it to constant in the flight mode you're in. So you have to go through each flight mode changing it to constant. Doesn't make any difference, it just saves you a little bit of time and hassle doing it on each one of them. Anyhow, let's have a little look. Let's think about this. This is going to control the gyro mode. And we've got 3 modes, so let's make gyro mode 1 is vectored thrust in heading hold mode for the hover. Gyro mode 1 is minus 100% travel. Gyro mode 2 will make vectored thrust in normal damping mode. And that's a 0% servo travel. Gyro mode 3 will make the normal heading, normal damping mode, but no vectored thrust getting stabilized. And gyro mode 3 is plus 100%. So let's set our gyro mode control. Vectored thrust, hover. This is where we want heading hold mode. And we've said that that's going to be gyro mode 1, which is minus 100%. So we've set the curve at minus 100. Go to vectored thrust normal mode. We've said vectored thrust normal mode, normal damping, will be gyro mode 2. Gyro mode 2 is 0%, so we've set the constant curve at 0. Normal fly around mode is going to be gyro mode 3, which will be normal damping mode with no vectored thrust. Gyro mode 3 is plus 100%. What about our other two modes? Takeoff mode, well, that we want to be gyro mode 3, which is normal mode, no vectored thrust. So we come in here, come down to the curve, set it there, and what do we want? We want gyro mode 3, which is normal damping but with no vectored thrust. Gyro mode 3 is plus 100%, so we turn that up to 100. Yep, we'll leave the point in there and simply go to takeoff to landing mode. Again, we want gyro mode 3, which is normal damping with no vectored thrust. Gyro mode 3 is plus 100%. So there we go. And now we can see switching between them. Landing mode will be gyro mode 3. Takeoff mode will be gyro mode 3. Normal fly around mode will be gyro mode 3. And vectored thrust normal mode will be gyro mode 2. And vectored thrust hover at minus 100 will be gyro mode 1. Okie dokie. Now we're beginning to get somewhere. And you would do much the same with the gains. As I say, once you've found out what gains you want, you would come in here, a constant curve for every flight mode you've got, and you can just dial the gain up and down to the exact value that you want in that particular flight mode. Okie doke. And I think that's it for that. Now we have to go and look at the assist itself. So get that set up. So we'll switch it on.
Initialized. Armed.
There we go. And let's have a look inside the assist. Okay, you've run through the wizard, you've got your bits and pieces set up, channel assignment. Don't forget, when you're doing assign the primary flight channels, that's especially for the elevator and the rudder, you must have the vectored thrust switched on. Otherwise, the assist will not see any movement on the vectored thrust channels, and it won't associate them with the stabilisation for those channels. Okay, so if you've done your stick calibrations and nothing you do will get the assist to stabilise the vectored thrust, it's because you had it switched off when you assigned the channels or calibrated them. Remember, when you move the stick, the assist looks at what channels are moving and says, oh, those are the channels I need to stabilise in that axis. And so, of course, if you've got it switched off and the vector thrust channels don't move, it thinks, oh, nothing there for me to do. Okie doke, so that's a little catch for you. And I wish I'd remember not to press OK, because it takes you right out of the menu. Okie dokie, down here. Right, channel assignment, the additional channels. The flight mode channel, that is our G mode channel. It gets confusing here because we tend to talk about flight modes as a transmitter flight modes. You know, we set up flight modes, flight mode trim and such. Right? This is really gyro mode channel, okay? And it's channel 7, which is the one that we are using to control which of the 3 gyro modes we're in. So if I move the switch, for instance, to normal flight mode, it should go to gyro mode 3. There we are. If I go to, here we are, I'll go to takeoff mode, it should stay in mode 3. Landing mode should stay in mode 3. Okay, now we'll switch to vectored thrust mode, normal, so it should go to flight mode 2. Yahoo! And I switch to hover mode, flight mode 1. Lovely. That's just as we'd planned it. Now, remember, you'll set a separate 2-position switch for your assist off, and your gain tuning channels will be as I've set up the gain functions. I've set it all up as simply one channel controlling both gains, but of course with the assist you can set up independent channels for each gain. Okie doke. Now you might have a problem when you come to assign that, because as you're moving the switch that would change the gain that we set up in those function curves, it will also be changing the flight mode channel, and the assist will look at the first channel, i.e. the lowest channel number that it comes to that it sees moving, and it will see that it's the channel 7, not channel 8, even though channel 8 is moving, so it'll pick channel 7. I must write to Jeti and suggest that they allow us a manual override for situations like this. So we can say, no, it's not that. But do watch out and go back and check in your servo assignments that it has picked up the correct gain tuning channels and the correct flight mode channels. Yeah. If you find that it keeps picking up channel 7 or whatever is the gyro mode channel instead of your gain tuning channel, then just come out of here, go right back in the menus to servo assignment, come down to the one that it's picking up erroneously and change that to blank. Then go back in, pick up your gain channels, then come back here and switch G mode back on again. Yeah, it works beautifully, but it's a little bit of a roundabout hassle, and that's why I think I might write to Jeti and suggest they do allow us an option of a manual override, because if you're doing more complex stuff like this, you can end up with multiple channels moving, and it might pick up the wrong one. Okay, so having set your control of the channel assignments, we come to the biggie, the flight modes. And let's just look through it. So we've set mode 1, we said was going to be the heading hold vectored thrust. Mode 2 we said was going to be vectored thrust with normal damping, and mode 3 was going to be normal damping but no vectored thrust. Let's just double check all our assignments of things. We'll go to the default flight mode. Should be mode 3. It is. Takeoff flight mode should be mode 3. What's that one? It is. Landing flight mode 3. It is. Okay, back to default. Okay, vectored thrust normal mode should go to mode 2. It is. And vectored thrust hover should go to mode 1. It is. Okay, that's fine. That's going to work. And that's fine. That's going to work. Here's where we have to tweak the settings inside the assist to switch off the stabilization of the vectored thrust. And we do that by going to Edit. We come down here, and now it lists all the axes that could be stabilized for each servo. Don't worry that it says it's stabilizing roll, pitch and yaw for throttle. It's not, because it didn't find the throttle channel moving when you did the calibration of the controls. Right, here we are, pitch and yaw. Let's have a look. Okay, roll, pitch and yaw. So we need to switch off the pitch for pitch and switch off the yaw for yaw. But if the menus disappear, it doesn't really matter. You can switch all of them off. Won't hurt it. Switch off yaw. I'll switch just yaw off there to prove that just switching yaw off and leaving pitch and roll in does not affect yaw. Okay? And that should have done it. Moment of truth. Now, here's where I need 3 hands yet again. Perhaps I ought to get some lovely assistant to come and help me. Right. Okay, switch that back to normal, back to there. And we're in default mode. Okay, let's see if I can get this to work. We're in default flight mode. So, what we have here is our 2-tail servos for the vectored thrust. There's the rudder, or yaw vectored thrust I should say, and there's the elevator vectored thrust. Now, if the model should pitch or rotate, they should not be stabilized, and they are not, because we're in default mode. Good. We shall switch briefly to takeoff mode again, just to show it. And no stabilization of the vector thrust. Goody good. Right, let's go to vector thrust normal mode. Okay, so now the vector thrust unit should be stabilizing in normal damping mode. There we go. As you can see it in yaw, it's giving a kick, and in pitch, it's giving a kick in normal or rate mode. And now let's finally switch to vector thrust hover mode. This should give us heading hold. Let's rotate it, and indeed it is. There's the yaw working in yaw, and the pitch doing heading hold in pitch. And there we go. It's all fairly straightforward. There's just a lot of it. And so I hope that's given you a good flavour of some of the fantastic things you can do to control your model, particularly this one. That's been a very long video. Normally I'd split it up, but I think it was better just to rattle through this in one. And we'll be back with twin rudder braking, depending on whether it's conventional or Delta model. See you then. Have a nice flying. Bye for now.